Alright, this is my statistics final project. I chose a 1 prop Z test. My question is, do you have any tattoos? So I chose this project because I'm 17 and I can't get tattoos yet. However, me and my best friend want to get matching tattoos when we turn 18, and this made me curious as to how many people have tattoos. My research question is, do you have tattoos? Just one or more. The data represents the percent of people who have gotten at least one tattoo. The alpha is 0.00 because it is standard. For my sampling method, I asked 50 people randomly by writing down the question and asking random people throughout my college, gym, supermarkets, family, friends, and work. The population is all people, and the sample is 50 randomly selected people. In order to avoid bias, I asked various ages, races, ethnicities, genders, and locations. I also went to each location at various times in order to get a wider variety of answers. As shown in the table, I had 16 people say yes, 34 people say no, which gives us a total of 50 people. This is also shown with a pie chart, as we see 34 people said no and 16 people said yes. The majority of our people answered no, which is 68%, and the percent of those who answered yes is 32%. So my hoe is P equals 0.32, or the proportion of people who have at least one tattoo is 32%. Ha is P is greater than 0.32, or the proportion of people who have at least one tattoo is greater than 32%. And then my citation is listed above. Reference it if you feel the need. So for the conditions, our first one is random and independent, in which our data is collected randomly as stated above. Second is large sample, in which population has to be greater than 10 times the sampling size, in which all people are greater than 500 people. So condition number 3 is the big population, in which n times p has to be greater than or equal to 10, and n times 1 minus p also has to be greater than or equal to 10. We get 16 is greater than or equal to 10, and 34 is greater than or equal to 10. This means that all of our conditions are met. So p equals 0.32, which is given. P hat equals 16 over 50, which is 0.32. N equals 50. Standard error is equal to the square root times 0.32 times 1 minus 0.32 all over 50, which gives us 0.004. Z equals 0.32 minus 0.32 over 0.004, which gives us 0, and p-value is equal to 0.5. Our test statistic is Z equals 0.00, and our p-value is p equals 0.5. This is also shown in the graph below. Since the p-value is 0.5, and that is not less than the alpha of 0.05, the conclusion is do not reject hoe. I do not reject hoe. There is not statistically significant evidence to reject hoe, p-value equals 0.5, and I conclude that the proportion of people who have one or more tattoo is not greater than 32%. For a confidence interval, we take 0.32 and add and subtract it to 1.96 times 0.004. We end up getting 0.32784 and 0.32216. So I am 95% confident that the proportion of people who have at least one tattoo is between 31.22% and 32.78%. So I have learned a lot from this project, and I thought that the percent of people who have tattoos would be larger, but I didn't actually know the range. This project allowed me to research the question, and I also got to discover cool stories about my peers and why they got their tattoos. I found out that the research done by myself and Vision Monday was accurate, and being able to connect the lessons to the real world was actually fun to do. It also made the course feel more relative to my life. That is the end of my statistics project, and I thank you for your time.